Another example of limit comparison test. So here we want to test this series given by 1 over n times the square root of n squared plus 1. We know that this is all positive because n is starting from 1. So we want to compare it with another series whom we know is also positive. Now, how will I find the series that I will compare with this? Well, I notice that the square root of n squared is also n. So I'm going to compare this with the p-series 1 over n squared. And we know that this p-series is a convergent p-series. So let's find the limit of 1 over n times the square root of n squared plus 1 over 1 over n squared as n goes to infinity. This will now be 1 over n times the square root of n squared plus 1 times n squared over 1. I reciprocate this one here. So simplifying this, we get n over the square root of n squared plus 1. To find the limit as n approaches infinity, I'm going to multiply this by 1 over n. Now, to show that 1 over n is what I'm going to multiply here, I have to put that under the square root sign. So 1 over n squared. That's the same as 1 over n. And so I will get here 1 in the numerator. N times 1 over n is 1. This one will give me now, let me multiply the 2, n squared plus 1 over n squared. And so that simplifies to 1 over the square root of 1 plus 1 over n squared. Now let me apply the limit. As n goes to infinity of 1 over 1 plus 1 over n squared, this will become 0, and so the limit is equal to 1. Because the limit is positive and finite, and we know that this p-series is convergent, then this series is also convergent.